first when we're doing these questions, we gotta like, it's just factoring. This is literally all this is. Okay, you look at it. Yes, the same?
On the test, will we have to show like all of our work for the factory?
No.
Is just the answer already?
That I don't like. I'd like to see, like, tell me what the multiples are and what you're adding to at least. Okay? Well, and, like, some of them need, like, the difference of squares probably doesn't need much work, right? Perfect square trinomials probably doesn't need much work, but the simple trinomials and the complex trinomials probably need a little bit of work there. Okay? Some of the quicker ones, like the difference and perfect square, those are pretty quick, right? Okay, so for the interest of this, right, simplifying, what our job here basically says simplify and state restrictions, okay? So we're going to say, okay, for number one, we're factoring number one. So how do I factor number one? I need two numbers at what? Okay, I need two numbers that multiply to 4 and add to 5. What are we going to get?
1 and 4.
1 and 4. Okay, 1 and 4 work. Now, is number one, the green one, a simple or complex trinomial? It's complex, right? Because the a value is not 1. Okay, so we're not able to go x plus 1 times x plus 4. That's not going to cut it. You got to decompose the middle term. So I'll rewrite the trinomial so we can see where this stuff comes from. We're going to decompose the middle term. We're going to get 2x squared plus 4x plus an x plus 2. Are we okay? This is just complex factoring. Okay, the other thing we'll do today is like, I'll type this big long thing into Desmos and we'll see what it looks like. Okay. Okay, so then break your question down the middle. This is just factoring by grouping now, right? What's common across the first two terms? 2x, right? I can take a common factor of 2 and I can also take an x. So I'm going to take 2x and then I'm going to tell everybody what's left after I remove it. By removing, when we're using terminology removing, it's division, right? So we get x, that's all that's left, plus 2. Plus, what can I remove from the other half of this equation? Evie? Just 1. They're both divisible by 1, so you can remove 1, no problem, right? Plus 1 times x plus 2. Okay, again, just to highlight, those two things match. They're now a common factor. You could probably write, don't forget your equal signs. We're going to see factor out that x plus 2 green piece, right? We're going to see x plus 2 times what's left, 2x plus 1. Okay, now your next line of this, the green piece is now, we've factored the green piece into its two factors. That's what it turns into. We just get x plus 2 times 2x plus 1, and we know that has to be divided by whatever the red piece factors. Is everybody okay? We are literally factoring 4 times. That's it. Okay? Sometimes you don't factor 4 times. Maybe it's 3 times if there's no common factor or something. Okay? I don't think in these questions I can't give you anything that's not factorable in these questions. They all have to factor. Otherwise, we've lost the point of these questions. Okay? But your approach is you see something, factor it. Make it easier. It's simplifying. Factoring is nice because it simplifies what it is we're looking at. Okay, so there is the first move that you're making. Okay, for the second one, this is going to be red. I'm going to need two numbers that multiply to what?
5.
Careful.
Sorry. Multiply to 6.
6, good. Add to 7. So that sounds like 1 and 6. Everybody agree? We're doing the red one now.
Sorry, I just wrote down 2. That sounds flawed.
Oh, sorry. My bad. Call this 3. 2's easy. We'll be done 2 quickly. because it's a simple trinomial. I just jumped to the more complicated one. Okay, so two numbers that satisfy those conditions are 1 and 6. So again, we just rewrite the trinomial. 2x squared plus 5x plus 2. Decompose the middle term to be, it doesn't matter, 2x squared plus 6x.
If there are any students who still need to get their pictures taken or retakes done, please come to the back of the cafeteria. Any students that need their pictures taken or retakes, please come to the back of the cafeteria.
It's like 5 plus 2, not...
Oh, sorry, I wrote the wrong thing there. That's why I'm not making sense here. 7x.
plus 3, not 2.
What did I write down?
You did
Oh, I did the top.
squiggle.
I did the the top one. I wrote down the top trinomial. Plus 7x plus 3. My bad. See, I knew I was catching that because in the next line here, I was going to get two factors that didn't match. That's fine. This part's fine. Okay, so now you're going to get 2x. It also has to be a 3, sorry. What's left after I move the 2x? You're going to get x plus 3, and then plus 1x times x plus 3. So we get x plus 3 times 2x plus 1. So that's your balance. And you can see right off the bat, something nice has happened right there already. Okay. These questions are fun. It gets more fun when you can actually like produce the graphs, but that's a later issue. Okay, kids don't think it's fun because they can't factor. That's obviously not fun if you can't factor. That's a nightmare. Okay, why I'm doing this is just to emphasize the importance of factoring. Opal? Okay. Okay, number 2 is the orange one. It's a nice one. We need two numbers that multiply to negative 30 and add to negative 7.
We'll have more space in the test, right?
Well, yeah, you'll have like a whole backside. Yeah. Okay. We need the numbers that satisfy the condition. Again, like I don't... the thing is about this lesson, like the grade 11 lesson, like most of the time you might not necessarily need to... I'm being pretty thorough here because I'm making a video, right? You might not need all these steps. You might not need all this room either. Okay. And so by grade 11, the expectation is you can do this a little quicker, right? This is not a... The space doesn't necessarily fit a grade 10 class, okay? So I'll leave you enough space on the test. But what are these? Well, 1 and 30, 2 and 15, 3 and 10. Do you think 3 and 10 we could maybe make work there? All right, so make it, which one do you want to make negative? Okay, because 3 take away 10 satisfies negative 7. And 3 times negative 10 obviously satisfies the negative 30. Okay, so, and the nice thing, what's nice about this? It's a simple trinomial. So when you find those two factors, you're done, right? You're writing x plus 3 times x minus 10. Okay. Okay, and the last one here is, we're just going to do some shuffling here. So I'm going to rewrite number 4, just like yesterday at the end of, oops, just like at the end of class yesterday. Okay, we're going to go negative x squared plus 6x plus 40. Okay, and then I'm going to, nobody wants to factor this the way it is right now. Would everybody agree? Don't make this mistake. Is the x squared by itself right now? No, there's a negative on it. So if you were to actually do this without doing anything smart, you would have to find two numbers that multiply to negative 40 and add to 6. And then, because it's not, this is a complex trinomial and currently, you'd have to decompose the middle term. Nobody wants to do that. Turn it into a simple trinomial. Right? Factor out that negative. So we get negative out front, x squared minus 6x minus 40. Now you can find the factors that work. And this is a simple trinomial now. Multiply to negative 40, add to negative 6, find the numbers.
10 and 4.
10 and 4?
Well, negative 10, positive 4.
Oh, well, that's fine. We'll go 10 and 4. That's always, I always like just checking the multiplying. Don't worry about the signs. You can fix the signs to fit, right? Then I need negative 6. The only way to have negative 6 is if it's negative 10 plus 4. Okay, so now this turns into x minus 10, x plus 4.
Do you not bring the negative? Or?
Oh, you're right, sorry. The negative 2. Sorry. That was on the whole time.
It was pretending. So is the x minus 10 on the top still going to cancel with the x?
Yeah. Oops, I'm out of room here. Plus 4. Okay. Now you get to do the fun part. You get to do some canceling. Now, before you do any canceling, okay, what should maybe you do right here? I know, we're tight for space here. What should we do? Remember what we're eventually going to graph. We're graphing the original, okay? And we've just made the original a little simpler so that I can see something. What am I looking for, Bryce? You have to say, what can x not be, right? And we know the restriction is that any of these cannot equal 0, any of them. If they do, you're dividing by 0 and you have a problem. So those are restrictions. We're not allowed to have anything in the denominator equal 0. Any value or some value of x that makes it equal 0. So we're just going to say x plus 3 cannot equal 0. That's from the red piece, right? We're going to have, so from that, we're going to see x can't equal negative 3. That's one restriction. Okay, also from the red piece, we can't have 2x plus 1 can't equal 0 either. And so 2x can't equal negative 1. X can't equal negative 1/2. That's also from the red piece. Okay, and then the only other piece we have in the denominator is the blue piece, right? So you go over and you say, okay, x minus 10 can't equal 0. So x can't equal 10. And then you also say x plus 4 can't equal 0.
Can you write them all in all?
Just wrote x cannot equal negative 3, negative 1/2, 10, negative 4. Is that fine too?
That's fine. I'm just showing you where it comes from, right? Because sometimes with these complex trinomials, you always get one of these funny mixed 2x plus 1 or 3x plus 4 or something. And then everyone's like, I don't know what. Like, is it 4/3? Is it 3/4? Is it negative 3/4? I just show it all the time to be the same thing. Okay, it's a process. Just follow the process. Now, last step to this. what's nice now? What are we allowed to do?
Cancel out.
We can cancel stuff because I don't have any. Here's the catch though. In grade 11, in addition to this and graphing, you will also see some with a plus sign here and a minus sign. And now you have to create a common denominator between them. I'm not doing that this year, but that's what's coming.
Do you remember how to do that?
Of course I remember how to do it. I remember that we do it. Of course I remember how to. How do I create a common denominator? I know how to do that. That I do know, sir.
Make it up.
Make it up. Okay, that's what's coming. In addition to all of this, in addition to having to produce the graphs, you also have to do these things with addition, subtraction. This unit is a nightmare for kids, especially the ones that can't factor. Good luck. Okay, did you say stop saying that? I'm just trying to listen.
You're instilling fear.
I'm supposed to instill fear because you know what fear does? Makes you go home and study. Learn it. Don't keep kicking the can down the road. That's gonna get you. Trust me, from experience. Well, you could be a little bit anxious, but this is a good. Listen,
Good anxiety.
it's not anxiety, but like it's better to have anxiety in these four walls than in the four walls of a university.
Fair enough.
Let's get back to the lesson.
Okay, let's finish this off. We can cancel those out. Boom. Then we can cancel those out. Is there anything else? There's an x plus 3 and x plus 3 we can cancel too. So here's what it reduces to. X plus 2 over x plus 4. Did I forget anything?
Yes.
What?
Negative sign.
The negative sign out front in the denominator. Careful. That's from right here. Don't forget that.
What's the semicolon mean?
That's now I'm just going to state something else now, right? I'm going to state the restrictions. X can't be -3, -0.5, 10, and -4. That's it. You're done. I'm going to hit stop here. I'm going to show you what this graph looks like on Desmos while you guys chip away at some stuff. And then we'll have a better appreciation as to A, how complicated this is going to be to produce as a graph. B, we're going to contextualize again what the restrictions actually are. Oh, actually, we didn't talk about one of them. I'm not going to worry about that. I only care, this is the end of the question, but I will show you next year some other things that you have to worry about. I might get IB trained.